Prepare to embark on a captivating journey into the world of agriculture, where technology and innovation converge to unleash a new era of farming prowess. In this video, we unveil a collection of awe-inspiring machines and tools that are propelling the boundaries of what's possible in modern agriculture. From the mighty self-propelled combine harvesters that devour vast fields with unmatched efficiency, to precision seeders that plant with surgical precision, and the intelligent irrigation systems that conserve water while nourishing crops, we'll explore a symphony of cutting-edge technology that's transforming the agricultural landscape. Number 5. Self-propelled combine harvester. The modern combine harvester, more often referred to as just a combine, is an agricultural equipment that can harvest a wide range of grain crops. The term comes from the fact that it combines 4 distinct harvesting processes into a single step: gathering, threshing, gathering, and winnowing. Wheat, rice, oats, rye, barley, corn, maize, sorghum, soybeans, flax, linseed, sunflowers, and rapeseed are some of the crops that may be harvested using a combine. Other crops include sunflowers and rapeseed. The crop's stems and any remaining leaves are what make up the straw that has been separated and left laying on the field. The straw has just a little amount of nutrients left in it, so it is either chopped up, put out on the field and tilled back in, or bales for use as bedding and limited feed for cattle. Combine harvesters are one of the most economically important labor-saving technologies, since they have greatly reduced the proportion of the population that is involved in agriculture. Number 4. Precision seeder. A precision seeder is an item of agricultural equipment that evenly distributes seeds throughout a field in a precise and time-saving manner, with the goal of speeding up the planting process. When compared to the conventional ways of broadcasting, in which seeds are dispersed randomly, this approach represents a substantial breakthrough. The precision seeder makes certain that each seed is planted at the appropriate depth and spacing, which leads to consistent crop emergence and increased potential yield. Precision seeders are able to attain their accurate seeding capabilities because they make use of a variety of modern technologies and systems. Planting units, seed hoppers, metering systems, and seed tubes are the main components that make up these systems. The seeds themselves are stored in the seed hopper, and the metering system is responsible for regulating the flow rate of seeds to maintain uniform spacing. The seeds are transferred from the hopper to the planting units, which then carefully insert the seeds in the ground, thanks to the seed tubes. Many modern precision seeders are equipped with GPS guidance systems and electronic controls. These features make it possible to align rows precisely and make automatic modifications to seed rates dependent on the circumstances of the field. Because of these technologies, farmers are able to maximize the effectiveness of seed planting and reduce the amount of seed that is thrown away, which results in cost savings and advantages for the environment. Number 3. Automatic irrigation system. The application of water to plants in a way that is both regulated and automated may be accomplished in a way that is both practical and effective with the use of an automatic irrigation system. It is devised to provide crops, gardens, or landscapes with the proper quantity of water according to the individual water needs of the crop, garden, or landscape. The usual components of an automated irrigation system include a controller, timer, valves, pipes or tubing, emitters, such as sprinklers or drip emitters, and sensors, which may or may not be present. The controller is the brain of the system and is where you will select the watering schedule, as well as the length of each watering cycle. The system is linked to a dependable supply of water, such as a municipal water supply, a well, or a reservoir in the ground. It is possible that it will contain a backflow preventer so that the water supply will not be contaminated. Water may be distributed in a variety of ways via the use of automatic irrigation systems. Sprinkler systems work by spraying water into the air in a pattern, therefore covering a wider area, while drip irrigation systems work by delivering water straight to the plant roots, thereby reducing the amount of water that is lost as a result of evaporation. Number 2. Soil moisture sensor. When you hear the term smart garden, one of the first things that could spring to mind is a system that monitors the moisture level of the soil and automatically provides the required quantity of water to the plant. This is one of the most important aspects of a smart garden. Because to this technique, plants may only get water when it is absolutely necessary, preventing either over or underwatering. A soil moisture sensor is an item that is very necessary to have if you plan on constructing a device of this kind. The sensor that measures the moisture in the soil has a simple method of operation. The fork-shaped probe has two exposed conductors, which allow it to function as a variable resistor, akin to a potentiometer, the resistance of which changes depending on the amount of moisture present in the soil. Number 1. Crop monitoring drone. The use of drones in the agricultural industry is on the rise, making it stand out from the rest of the economy as having the fastest growing rate of drone adoption. The market for agricultural drones is projected to expand from its current value of $1.2 billion USD in 2019 to reach a value of $4.8 billion USD in 2024, according to certain studies. In just a few short years, the usage of drones on farms, both large and small, will become increasingly common for a variety of purposes, including reconnaissance and security. It is common practice to use the data collected by drones on farms to better guide agronomic decisions. This practice is a component of a system that's commonly referred to as precision agriculture. In many regions, the utilization of drones has already developed into an integral component of large-scale precision farming operations. Farmers are able to better plan their planting and treatments thanks to the data obtained from drones flying over their fields while documenting the crop's conditions. According to a number of surveys, the use of precision farming systems can result in a rise in crop production of up to 5%, which is a considerable improvement in a sector that traditionally has low profit margins.